I'm showing the first example of an improved experiment, I think. And the idea is to do the lever launcher. Okay, so you just got a spring over here and you're going to push something. So this is all horizontal. So again, you're just like looking down at it from above. And instead of launching, just have the masses attached. And so then you can use the same exact object, have two of them here, one short of the distance, one a little bit further out. And then one mass at two distances. And all you have to do is measure the speed of the lever itself. So if you film it exactly from the same camera position, you could just superimpose the two experiments on top of each other and see if the lever moves exactly the same. And if it moves exactly the same, then that's basically telling you one mass creates twice the velocity, two mass half the velocity. Now obviously if you have a timing gate, you could just put a little card on the end of the fulcrum and at the end of the lever and just measure how fast it goes through the, and it's as long as you put it in the same exact position, it doesn't matter where it is on the arc, because the acceleration is going to be the same for the lever. Accelerating the two mass at one velocity, it's going to take exactly the same time as accelerating the one mass at two velocity.
Okay, so I gotta be honest, this is actually quite a good idea as an experiment. So I'm gonna test it out. So this is just a first simple trial. I can try to improve it in the future. So here is the lever, the small wooden lever with the spring. Here we have a 10 centimeter mark. Here we have a 20 centimeter mark, so one distance, two distance. Here's the timer. So I will pull the stick back to this point. And when I let it release, it will stop at this point. And at this point, it is just right behind the timer. So as the lever passes through the timer, once it hit the stopping point, that's when it's just beyond the timer. So hopefully this is going to be the maximum velocity. I'm going to shove the one mass to the two distance mark. Then pull it backwards. I'm going to do 3 trials with the quick release. So with a thread and cutting the thread. And then I'm going to shove the two mass over here. And then see what the timings are. One mass, trial 1. 45. One mass, trial 2. 44. One mass, trial 3. 45. 36. Two mass, trial 2. 38. Two mass, trial 3. 38 again. Okay, same experiment but different lever. I'm using the carbon rod, which is 1 meter long. I'm going to try out the one mass, two mass, and then a four mass. So the one mass at 4 distances, and then a two mass at 2 distances, and a four mass at 1 distance. Now, there was a little problem. There are always problems. When I suspend the mass over here, and on this side I have no mass. When I suspend the mass over here, then the lever will drop to the bottom here, and so that's not good. What I've done to prevent this is put a little bar at a certain height so that the lever can rest on top of it. So now the lever slides over this bar, but the lever stays now at the same height. Otherwise, when I let it go, it would drop down onto the bottom here. So I've used this bar. Hopefully it's an iron bar, so hopefully the amount of friction is minimal. But yeah, that's a problem. Otherwise the lever will fall down and it will go like this. Instead of in a straight line, it will move like this and then collide into the floor under the bottom, and yeah, that was no good. So once again, we have the timer over here. So I pull the lever back to this point. I let it go. It will go through the timer and then stop to this point. Alright, so let's give it a shot. Okay, one mass, 4 distance, trial 1. 71. Trial 2. 69. 71. 70, 70, 70, 69. I think it's pretty clear. 70. One more and then I'm done. 69. Okay, so pretty obvious. Okay, we got the two mass hanging at the two distance. There we go. $55. Right. Again. 55 again. And 55 again. 55 again. $56. One more try. $56. Okay, that's enough. Okay, now I got the 4 mass suspended at one distance. 4 discs. There we go. 46. 46 again. 47. 46. 47. Very consistent results. One more try. 46. Okay, that's it. So, once again, as we saw, thanks to the timings, the 1 mass further out on the lever took more time than the 2 mass closer in and the 4 mass closer in. So even though we put heavier masses closer to the fulcrum, they went faster than the 1 mass further out. So once again, the moment of inertia is demonstrated here. The more further away the masses are from the fulcrum, even though they are lighter masses, it still requires more kinetic energy to spin the lever. That's what this demonstrates. So whether you like this or not, you're going to have to accept this reality. This is being demonstrated to you dozens and dozens of times in many various ways. And now this is one of your own proposed experiments, and still it shows that moment of inertia is a real phenomenon. Now you're going to once again say there's a flaw over there, a flaw over there, it's crap, it's bullshit, it's garbage experiment, try this, try that, okay, fine, let me go ahead and let me try to do it, repeat the experiment in many various ways once again.